physics, when we talk about speed or velocity, there's two types of speed and velocity we can talk about again. This seems to be a reoccurring theme in physics. We have analog versus digital types of measurements, and we have scalar versus vector types of numbers. But when we talk about velocity or speed, we can talk about instantaneous or average. They are two really different things. Let's take a look.
Alright, the difference between instantaneous and average speed and velocity. Now once again, you know how I love my little red Ferrari, and I get in my little red Ferrari and I start driving away at 100 miles per hour. Now, what kind of number is that? Is that a scalar or a vector? Currently, it is a scalar number because there is no direction associated with this number. So that is a scalar number. And actually, the device that I am looking at inside of my car is called a speedometer. Speed is a scalar kind of number. The speedometer, though, tells me just at this very instant how fast I'm going, 100 miles per hour. You know what? That might change the very next second. For example, if I take my foot off the gas. So instantaneous speed is a very quick measurement. How fast am I traveling right now? You can think of it as one frame of a film. If I just look at the speed in that frame of the film, that is my instantaneous speed. But what if there's a policeman here and he's watching me and he's got his little badge on. He is watching me over the long distance and he watches me go past a mile marker. Let's say that this is mile 0, and then he records how much time it takes for me to travel from the 0 mile marker to the 1 mile marker. The police watches over a very long period of time. What he is looking at is my average speed. This is over the long term, how much time it took me to travel a distance from 0 to 1. Well, what's pretty cool is I can find out my average speed, or velocity, by taking a summation of all the instant velocities in my trip. Now, summation means to add it all up. Let me explain. Here's my Ferrari, once again, and I have not put my foot on the gas yet, but I look down at my speedometer, and I see that it's reading 0 miles per hour, right? I'm not moving yet, so I'm reading 0 miles per hour, and right here's my start line. So I put my foot on the gas, and after a little while, vroom, 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 I'm traveling 40 miles per hour because my speedometer tells me so. That is an instantaneous speed. But then, sometimes later, vroom, 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 I'm traveling 80 miles per hour, and I can tell that because I look at my speedometer once again, and I'm crossing the finish line. So I have 3 unique instantaneous speeds. But if I want to figure out my average speed, all I have to do is take my first speed and add my second speed and add my third speed. And considering that this is an average, I'm going to divide by the number of measurements I made. In this case it was 3. When you run the math, I get an average speed of 40 miles per hour. So this is average speed.
So using the CPO equipment, how can we measure these two different types of speed? Well, Instant utilizes one of these. These are the carts, or the little cars that we are going to be using in our physics class. And do you notice that there's this little jut right there? And this is really critical because when you have a track that cart runs on, that little jut right there blocks the beam of light that we played with. In other words, turning on and off our timer. Wait, if it turns on and off our timer, we have the time element of speed, right? We still need distance. Question, where do we get that? If we know the distance from this side of this little plastic piece to this side of this little plastic piece, we're in business.
So, how do we use the CPO equipment to measure different types of speed or velocity? So, if we take a look at instant speed, if speed is distance, in this unit meters, and this is going to be the unit that I measure distances in my class, and time in seconds, which just so happens to be the same unit that the CPO timers work in, I would be able to calculate speed. Now, if you take a look, the top of my cart, or little car for the CPO, has this blue flag, we call it, this plastic piece. And they were very, very careful when they made it, and it was exactly 1 centimeter across. I see a problem though. Look, the flag is 1 centimeter across, and I'm looking for distances in meters. So I have 1 centimeter, but I need to convert it into meters. How am I going to do that? Yep, you guessed it. This looks like a dimensional analysis problem. So the question is, how many centimeters are in 1 meter? If you think about cents in a dollar, how many cents are in a dollar? 100. Good. Now the only question is, I'm going to form a ratio. What needs to be on the top and what needs to be on the bottom? If you said eventually I want to cancel my centimeters with some unit in the bottom, which one is it going to be? Good. I want centimeters on bottom so that I can cancel my units, and that makes meters on top, which is the unit I eventually want. Okay? Well, when you put this in your handy-dandy calculator, you learn that you'll get 0.01 meters. You should learn this number because you're going to be using it very, very frequently. So, I can use the CPO timer to calculate the amount of time it takes the 0.01 meter flag to pass through that photogate. And this is my instant speed.
We've established that we can find instantaneous speed by using the CPO cart and the timer simply by using one timer. But what happens if we use two? If we use two timers, let me remind you once again that the CPO cart is going to turn on the timer as it goes through one and off the timer as it goes through the second photogate. And we can measure average speed.
Once again, if we set up our CPO track so one photogate turns on the timer and one photogate turns off the timer, the CPO timer is going to give us this information, the amount of time it takes to travel from one to the next. The only information that we need to supply is to take a meter stick and measure the distance from here to here, and that becomes the information on the top, and that gives us our speed average.